Hi everybody, this is lesson 14 and we are converting rational numbers to decimals using long division. So go ahead and copy down your essential questions. What is another way to write fractions as decimals, and how do we set up division problems correctly? You actually can get your calculator out for example 1. So go ahead and get a calculator for example 1. It can be on the computer, phone, your calculator that you always use, but you can use it right now. What I want you to do is I want you to take the following fractions and divide them in your calculator. It's just division. So do 1 divided by 2, do 1 divided by 3, do 1 divided by 4, all the way through 11. So go ahead and write down all of these and then write down what you get when you put them in your calculator. And I'm also just going to sneak in 1/11th over here. Okay, write down what you get, and some of them are going to be a little simpler than others, but we're going to see if we can notice any patterns. Okay, so if you're watching this, you already did 1 divided by 2 and you got 0.5. If you're not done, pause it until you are done. Okay, 1/3 is 0.333. It goes on and on and on. 1/4 is 0.25. 1/5 is 0.2. 1/6, this was another weird one. It's 0.1666, and then it goes on and on, so I put those dots. 1/7, this one is really strange. It's 0.142857142857 if you kept it going. So that one looks really strange, but it actually looks like the digits repeat. It depends on how many digits you can see in your screen in order for you to be able to tell that. Okay, and then 1/8, this one's not too bad, 0.125. 1/9, this one's also interesting, it's 0.11111. And 1/10, hopefully you know 1/10 from our last lesson because the way you say it is the way that you write it, 1/10. And then 1/11th, that's the last one that's a little odd, but it does have a pattern. It's 0.090909, and then it goes on and on. Okay, so what did you notice? What did you notice? Some of them go on forever and ever, and some don't. So what we're going to write here is the word terminating. And that means end, ending. And then on the other side, we're going to put repeating or non-terminating. Actually, let's just do repeating, and we'll say goes on forever. Okay, these are all rational numbers because they either end or they repeat. There are some decimals like pi, if you're familiar with the symbol pi, that one doesn't repeat and it doesn't end. So there's, random, well, I won't say random numbers, but they're non-repeating numbers forever and ever and ever. These ones, even if they do go on forever, they repeat, so there is a pattern. Okay, let's go ahead and write these. This one, in the terminating side, we had 1/2, so we're looking above here. 1/2 ended nicely. 1/4 ended nicely. So did 1/5. 1/8 ended nicely. And so did 1/10. On the other side, we're going to have all these that go on forever and ever. So that would be 1/3, 1/6, 1/7, 1/9, and 1/11. Okay, we're going to look right now at the denominators. So go ahead and take a look at the denominators. In this one, the denominators are 2, 4, 5, 8, and 10. And on this side, the denominators are 3, 6, 7, 9, 11. There actually is a pattern between the denominators here. The reason why the ones on the left side do end nicely is because they have common factors in their denominators. So 2 is just multiplied by 2 and 1. So 2 can't be factored anymore, so it's just 2. The number 4 can be factored, though, to be 2 times 2. So see, we're kind of breaking these apart. Okay, the number 5 is just 5. The number 8 can be broken down. You can write 4 times 2, but 4 we know can be broken down to 2 times 2. So we actually have 3 of those. 2 times 2 times 2 gives us 8. And then for 10, we have 2 times 5. So are you noticing a pattern here? They're all 2s and 5s. And here's why. What's really cool, if you think about it, 2 times 5 is 10, and that's what our decimal place is based on. So there actually is a reason why those end nicely, because they either have a 2 or a 5. And then on the right side, we're going to notice that that doesn't really happen. Over here, 3 is just written as 3. 6 can be 2 times 3, but again, it's not just 2s and 5s. That one also has a 3 with it. The 7 is just 7. The 9 is 3 times 3. And the 11 is just 11. So again, you're noticing that those are not made up of 2s and 5s. So that way, that's part of the reason why those will go on forever and ever. They can't end nicely. And to kind of further prove that, right now we're actually going to do long division. So now you can put your calculator away. We're going to see how your math facts are. So as we continue on this lesson, you're going to notice something. You either follow it and you get the multiplication and division problems, you remember your math facts from elementary school, or you're like, oh, I haven't really looked at those in a while. I didn't really study them that well when I was supposed to. So you may find out that this is going to be a struggle for you. And there are things that I have for you specifically if you want a little extra practice. Okay, so the first thing we're going to do is we're going to write negative 3/4 as a decimal. Well, if it's negative 3/4, I know that it's a negative answer because the 3/4 is the whole thing is negative. We have to understand the division problem here. 3/4 means 3 divided by 4. And a common mistake that a lot of kids make is they write this. They write 4 divided by 3 because they say, well, 4 is the bigger number. It doesn't matter. You can have 3 cookies divided by 4 people. You can have 3 of something divided by 4. So 3 cookies divided by 4 people. What I want you to realize, this reasonableness, is that our answer is going to be less than 1. Not everybody's going to get a full cookie. Okay, I would need 4 cookies divided by 4 people at least to have more than 1. So the good thing here is we can do 3 divided by 4. It's not that difficult of a problem. Just make a little note that says 3/4 is less than 1. So we're using reasonableness. If I know that 3/4 is less than 1, I know that my answer needs to be less than 1. And in this case, it'll be a negative answer. So I was talking about the absolute value there. Okay, 3 divided by 4 is set up like this. I like to right away go ahead and just add 0.00 because $3. It's nice to have the decimal and the zeros there before we start. They'll be ready to go for us if we need them. Okay, how many times does 4 go into 3? No times. Make sure you always put that decimal straight up in your answer. Okay, now I'm kind of looking at 30. So how many times does 4 go into 30? It goes in 7 times because 4 times 8 would be too much. 4 times 7 is 28. And when I subtract, I get 2. And then I bring down the 0. Now how many times does 4 go into 20? I'm always happy when I see this because I know it works out nicely. That's going to tell me, phew, I'm done with the problem. It goes in 5 times. And since 20 minus 20 is 0, I don't need any more zeros. I don't need to keep going because it's just 0.75. And then we know our answer is negative. So negative 0.75. Okay, some of you might be thinking, like, Mrs. Kamak, you told us how to think of 3/4. I already knew it was 0.75, or maybe you knew it from before. So yes, that you should know 3/4 because if you think of money, 3/4 is 75 cents. So I'm glad that a lot of you are thinking, like, I already knew that answer. But this is showing you how the math works, and it's proving to you how to actually divide. So let's go ahead and do letter A together, and then I'm going to give you the challenge of trying letter B by yourself. So for negative 7/8, I know that my answer is negative, but now I need to set it up as 7 divided by 8. My advice to you was to put the 0.000. You can add, it doesn't matter how many zeros. Once you're done, you can stop, but it's, that's a little excessive. So we don't need all that. I'm just proving a point here that you can add as many zeros as you want after the decimal. Okay, 8 goes into 7 0 times. So again, my answer is going to be less than 1 because 7/8 isn't quite 1. How many times does 8 go into 70? Well, what's 8 times 8? 64. 8 times 9 is 72, so that is too much. So 8 times 8 gives us 64. Again, this is where I was telling you that your math facts might come into play. Bring down the 0. Well, at this point, 8 is too much because it can't go in 8 times because we know that's 64, but it can go in 7 times, which is 56. When I subtract that, that's 4. And when I bring down the 0, this is my happy moment because I see that 8 does go into 40 evenly. It goes in 5 times. And that's it. That's my final answer, negative 0.875. Okay, now for the next one. I want you to try this by yourself. I want you to set it up with pencil, no calculator. Try it. And my hint to you is that it's going to have 4 decimal place values, 4. So don't get too frustrated. I know sometimes if you start to do this, you're like, when is it going to end? Well, I'm giving you a hint. It's going to end after 4 decimal places. Okay, ready, set, go. Pause it and try it. Okay, if you're watching me, that means you already have this written down, you already have your work, and you're just seeing if you did it correctly. Okay, 16 goes into 30 once, with 14 left over. And then I actually had to work some of these off on the side here. I needed to see, okay, 16, how many times does that go into 140? So I did 16 times 8 here. And I said, okay, this is 48, carry the 4, 12, 128. Yeah, one more time would be too many. So I know that this is going to be 8. Then I already did the math, so 128. And now if I subtract that, I get 12, bring down the 0, 120. Okay, so how many times does it go into 120? Well, probably not 8, so it's probably going to be 7. Let's double check this because I need to know the number anyways. Okay, 112. So 7 times 16 is 112. And I subtracted, and I told you it was going to be 4 place values. So that's good because now you already know from me telling you that it's got to work out evenly. And I know to end in a 0, that's a good chance that it's got to be that 5. And 5 times 1 plus 3, 80. Very good. Okay, so that equals 80, and then I have nothing left. So that's my final answer, 0.1875. Okay, let's go on to the next page where we have 1/3. 1/3. You already know the answer to this because we did it on the first page, but here's why it repeats. If I do 1 divided by 3, it's going to be less than 1, so 0.00. Keep going if you want. 3 doesn't go into 1, but it does go into 10. Remember, you want to look at it like this. If I subtract 9, I get 1, and then I bring down the 0, and I have 10 again. So 3 times 3 is 9. And then I have 1, and I bring down the 0, and then I have 10, so 3 goes into 10. So you are definitely noticing a pattern by this point, okay? And it keeps going. It's always 10, and then it goes in 3 times. So then I subtract 9, I get 1, I bring down the 0, so on and so forth. So it's always going to be that. Okay, so that one is 0.3. Now, if the 0.3 repeats, that's the only part that I put the fraction bar over. Okay, and that's your answer for example 4. You try exercise 2 right now. Go ahead and try exercise 2. 4 divided by 9. And it's going to be negative, by the way, because it's a negative. Okay, like I said, put down as many zeros as you want. 9 doesn't go into 4, but it does go into 40. It goes in 4 times, because 4 times 9 is 36. 5 times 9 would have been too much. Okay, if I subtract, I get 4. Bring down the 0. Again, I'm going into 40, so 4 times 36, 4, bring down the 0. And I don't really need to keep going. So hopefully you kept getting that 40 over and over, and you subtracted 36. So it's 0.4, and that's the only part that gets repeated. So it's 0.4 repeating. Okay, the last one on this page we're going to do together. So I want you to write 1 divided by 11. And then again, put all those 0.000s. That's going to really help you not have to do that later. Okay, so 11 doesn't go into 1. Oddly, though, it doesn't go into the next one either. So even when I go over to 10, 11 is more than 10. So it doesn't go into 10. Now I need to think how many times it goes into 100. And that's 9, because 9 times 11 is 99. All right, when I subtract, I get 1. But watch this. It doesn't go into 10, so we have to put a 0 above that place value. Now I can bring down another 0 and say, okay, it goes in 9 times. 99, 1, bring down the 0. It doesn't go in. I think you're realizing that it's going to be repeating again. So let's go ahead and just put a repeating bar over the ones that repeat. So it's 0.09090909. I only need to put a bar over this 09 right here because that signifies that the 09 is what gets repeated over and over. Okay? All right, that's going to be a wrap actually on lesson 14 because you're going to skip page 84. You can actually skip page 84. And then on page 85, I want you to try that right now. So go ahead and try the problems for 85 right now. They are basic word problems in which you are trying to figure out how much money each person would have to pay. My hint to you is that it's Eric and his 4 friends that are taking a road trip across Illinois, and the tolls are going to be $8. Okay, so be careful. It's Eric and 4 of his friends. That's my hint to you. And then there's kind of a twist on it here. Okay, so this one is going to be terminating, and this one is not. Okay? Okay, so go ahead and try those two, and then we'll go over those in class. You can also do the summary, and then, of course, the independent practice will be in class. Okay, all right, that's a wrap on lesson 14. Bye.